Well, g'day Year 7s. Today we are looking at area of all different sorts of shapes, okay? Alright, so what are our learning intentions? We would like to today be able to measure the amount of 2D space shapes occupy, which is called area, and we'll talk about that in more detail if you find that sentence confusing shortly. We're going to learn how to convert between different units of area, which is very similar to converting between different units of length, just slightly different numbers involved. And we're going to look at and use a whole bunch of different formulas for calculating the area of different shapes. Okay. So let's dive straight in to the concept of area. So what is area? Okay, well, let me just turn my pen on here. Area. What is area? Well, area is simply the unit of measurement that we use to explain to someone how much space fits inside a two-dimensional object that is closed. Okay, that sounds very complicated, but it's extremely simple. Here is an example of a closed two-dimensional object. It just happens to be a rectangle. It has, in this particular case, it has straight edges, and wherever you start also happens to be the place where you finish. You can't have something like this and find the area of it. It needs to be closed, all right? So we're looking at measuring how much space fits inside of these sorts of shapes. Now you might ask, well, how would we go about doing that? I mean, how do you measure space? We can't use centimeters, that measures, or meters or kilometers, that measures length. We want to measure space. So one way of thinking about it is to ask yourself, if you have a closed 2D shape like this rectangle here, turn my pen on again, how many squares can you fit inside it? Okay, well in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares, okay? So, is it just sufficient to say that the area of this rectangle is 12 squares? Well, not quite, because we don't know what the side length of those squares are, or the person you're telling doesn't know what the side length of those squares are. So you would need to say the area of this shape is 12 centimeters squared. Why centimeters squared? Because it consists of 12 of these guys. And this guy here is a square where each side length is 1 centimeter. And we call that a square centimeter, or a centimeter squared, or the way that we're going to be writing it usually is like this, centimeters squared. Literally means a square where every side length is 1 centimeter. And then of course you have meters squared where every side length is 1 meter, and kilometers squared, and millimeters squared, okay? So obviously this particular example here is a very nice example because we get a nice whole number, 12 centimeters squared fit exactly inside of this rectangle. But when you get to things like circles, you will pretty much see straight away that when you try to fit squares inside of this, at the edges you're going to have parts of your squares sticking outside of the circle and parts of your squares sticking inside. So that's when you'll start getting decimals for your answers quite often. And that's when we start needing special formulas to figure out the exact answer for the area, okay? All right, but we'll get to that in a bit. Before we get there, what I want to do is quickly talk about converting between different units of area, okay? Because this is important. It was important in perimeter with converting between areas, different units of length rather. Because if you needed to figure out the perimeter of a rectangle, and some side lengths were given in centimetres, some were given in millimetres, you had to convert those side lengths into the same units before you could add them together. Okay? So we have a similar diagram to what you had for length, but for area. And you can see here we can get from millimeters squared to centimeters squared to meters squared to kilometers squared. In any direction, we can go from this direction to this direction, or this direction to this direction. We just need to follow the instructions that are written above or below. Now, the thing that students usually don't notice is that when we're talking about area, instead of length, we have divided by 10 squared, not divided by 10, to get from millimetre squared to centimetre squared. When we're getting from centimetre squared to metre squared, we divide by 100 squared, not 100, and so on and so forth. So that's a common mistake to look out for. Okay? All right, moving forward onto a couple of examples. I just want to do a couple of examples of converting between units of measurement in the context of area, just to make sure you understand. So, simple question, convert 1.3 million metres squared, which is an awful lot of space, into A square kilometres. So let's do that first. All right, so I need to get from metres squared to kilometres squared. And to do that, which arrow do I follow? Well, I'm not going to follow the bottom arrow because that's pointing in the opposite direction. I'm going to follow the arrow that's pointing in the direction that I need to go in, from metre squared to kilometre squared. So all I need to do is divide my number by 1,000 squared. So as you can see here, I've written 1.3 million metres squared equals 1.3 million divided by 1,000 squared in brackets, and that will give me the number of kilometres squared. And then I do the actual calculation in brackets and I get 1.3 kilometres squared. Okay? Isn't that amazing? You get such a small number from such a massive number after just one conversion. That tends to happen with area. All right. Now let's convert the same figure into squared centimetres, or centimetres squared. So we have 1.3 million metres squared. So I have to get from metres squared to centimetres squared, which means that I have to multiply my number by 100 squared. Okay, so this time I'm multiplying because I'm going into a smaller unit of measurement, centimetres squared. So 1.3 million times, in this case, 100 squared, centimetres squared. I do the calculation, and I've written it here, if you remember, we did this in term 1, I've written it in scientific notation, 1.3 times 10 to the 10 centimetres squared. But you could just write, let me think, what is that for a second? Yeah, so that's 13 billion centimetres squared. 13 billion centimetres squared. That's a lot of little squared centimetres. Okay, moving on. So now we're going to look at some different shapes, some real common shapes, and the formulas that are used to determine their area. Okay, so I'm going to zoom in for some of this. Let's start with these four here. The area of a square is simple. It's the same as the area for a rectangle. So let's do a rectangle first. The area of a rectangle is length times width, okay? And that makes sense because if you think back to our example where the area of our rectangle that we did a few moments ago was 12, I think it was centimetres squared, okay? It had a length of 4 and a width of 3, and 4 times 3 is 12. Okay, so that formula obviously works, length times width. Now the area of a square is exactly the same, length times width. But for a square, the length and the width will always be exactly the same. So instead of writing length times width, we just write length squared. But if you wrote length times width, that wouldn't matter. You get the same answer. By the way, don't fuss too much over which side is the length and which side is the width when you're thinking about rectangles, because it actually doesn't matter. Area also equals width times length. The order doesn't matter. All right, let's look at this parallelogram here. Now the formula for the parallelogram is base times height. So the base is this and the height is the vertical, okay, or this line here. Sometimes people think it's this line, which it's not, okay. We have the base times the vertical height. Okay, and I guess it's important to actually give you some details about exactly what a parallelogram is. Well, it's simply a pushed over rectangle, okay? A rectangle that's sort of sloping over a little bit. More specifically, it has, let me turn my pen on, 2 pairs of parallel sides. That's one pair. This is another pair. And these 2 angles will be the same. And these 2 angles will be the same. Okay, but this angle won't be the same as this angle. Now, in terms of the formula, why is it base times height? Well, that's actually easier to demonstrate. If I cut, imagine that's a straight line, that triangle to the left of that pink line, if I cut that off, and then I inserted it in here, what I would get is a perfect rectangle. See? Excuse my terrible drawing. And the area for a rectangle is length times width, which is another way of saying base times height, really. So that's why we get a very similar formula for the area of a parallelogram. Just don't make the mistake of thinking that this side length, the diagonal, is the height. Okay? Alright, so what about the triangle? Well, the area for the triangle is a half base times height. Okay? A half base times height. Well, if we, instead of thinking of base times height, let's just think of length and width again. Well, a triangle, if you cut a rectangle in half, you get a triangle, don't you? This bit in here. So the area of that pink part of that rectangle would be a half length times width, because it's half the area of the rectangle, okay? And it turns out that the area, and this can be demonstrated, it turns out that the area for every single triangle is a half length times width, except we don't say length and width. Once again, we say base and height. Importantly, the height is the distance from the very tip of your triangle, and you drop a vertical line down to the base of your triangle, okay? That's why height is this distance here. And sometimes it needs to be drawn outside of the triangle, okay? Because there's nowhere inside of this triangle where I could draw that height line. Once again, don't make the mistake of thinking that this diagonal side length is the height. The height is always the vertical, okay? And the base is simply the side that is parallel to the ground, all right? So area equals a half base times height. Okay, now we've got 4 more shapes that I want to go through, but I'm not going to talk about where the formulas come from in as much detail because that just takes up a lot of time, and you'll get to do that in future years. And you can research it yourself if you like. I'm just going to go through the shapes and tell you their formulas. So the area for a trapezium. Well, what is a trapezium? Trapezium is a quadrilateral, which means a 4-sided shape where you have 1 pair of parallel sides, see here, 1 pair of parallel sides, and 1 pair of sides that don't have to be parallel. The top is called A, the bottom is called B, and the formula is a half bracket A plus B times H, which again is the vertical height, not this diagonal side length. Okay, now a kite. What is a kite? Well, a kite is a shape that has 2 sets of, it's a quadrilateral that has 2 sets of lines that are the same length. So this is the same length as this, and this is the same length as this, but this length is not the same length as this length, okay? Plus, this length here and this length aren't parallel, okay? And the formula for that guy is a half x times y. X is the distance across the middle here, from the top to the bottom of the kite, and y is this distance here, from this point to this point, okay? All right, a rhombus has the exact same formula, all right? And if you think about it, a rhombus is just a special example of a kite where it just so happens by fluke that all four sides are the exact same length, okay? All right, so that one's straightforward. So finally, let's now look at the circle, which is perhaps the most important. Squares and rectangles as well, for us I mean in Year 7, okay? Now we all know what a circle is. Every single point around this circle here is the same distance away from the center of the circle, this point here, and the line from the center of the circle to anywhere on the edge, a straight line, is called the radius, all right? And we have a very simple formula for the area of a circle. Area equals pi times the radius squared. And pi, remember, is 3.14, blah, 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 blah. Okay, so those are our formulas that we need to be able to use, sometimes in combination with each other. So time for some practice examples. All right, find the area of the following shapes. So let's take a look at question number 1. We have a circle with a radius of 4 centimeters. The area is pi times the radius squared, which is pi times 4 squared. And I taught you in the last video, I think, where to find pi on your calculator. So you find that button pi on your calculator, you press it, and then you press the times button, and then you press 4 squared, and you will get 50.27 if you round to 2 decimal places like I have done. And then you look at the units, they're centimeters, so we know that our units for the area are in centimeters squared. All right, well, what about a semicircle? Okay, well, if the area for a circle is pi r squared, then it makes sense that the area of a semicircle is going to be pi r squared divided by 2. Okay, so we simply substitute the diameter in, which is 5, not 10. I said substitute the diameter, excuse me, I meant the radius. We substitute the radius in. I nearly made a mistake there, which is half the diameter. And if the diameter is 10, that radius there must be 5. So pi r squared over 2 equals pi times 5 squared divided by 2, which equals 78.54. We look at the units here, which are meters, so the area units are meters squared. Okay. All right. And here we have a triangle, and we know that the formula is a half base times height. Okay. Well, it's a simple act of substitution. That equals 1/2 times 7 times 2, because the base is 7 and the height is 2. Sometimes I'll even give you a number here for the side length, just to throw you off and try and trick you so that you'll think that's the height. No, the height is this vertical line. And we get 7 centimeters squared. Okay? All right, one more example. A tricky one. What we call a compound shape. If I can actually scroll down. All right, here we go. So what on earth is going on here? Well, if you think carefully, this is a lot easier than it looks, okay? Now, we can assume that this hole here is a semicircle. That's a reasonable assumption to make. when you see diagrams like this in Year 7 textbooks, they're expecting you to make that sort of assumption. If that looks like a semicircular hole, then that's what it is, okay? So we can think of this, before that semicircle, imagine this was a piece of cardboard, before that semicircle was cut out, we had a rectangle, okay? And the area of that rectangle would have been length times width. But we don't have a rectangle, we have a rectangle with a semicircular hole in it. So we need to find the area of the original rectangle minus the area of the semicircle that was cut out with a pair of scissors and tossed away into the rubbish bin, okay? So that's why I have written rectangle minus semicircle will give us the area. What is the formula for a rectangle? Length times width. What is the formula for a semicircle? Well, it's a half because it's half a circle times the area of a full circle, pi r squared. And then we just substitute in our numbers. So, imagining this as a rectangle, length times width is 10 times 12, or 12 times 10, it doesn't matter. There you go. I've done width times length. All right, now for the second bit, minus the area of the semicircle. So this coloured in bit here. So a half times pi times the radius squared. Now you might be thinking, where is the radius? All I have is this 12 and this 10. Well, if this is 10, then we know that this here is also 10. And then we know that half of this 10 here must give us the radius, and half of 10 is 5. So that's where I get this 5 from here. And if we figure out that calculation, you can put this into your calculator just like that, and it will do the BIDMAS for you, and you will get 80.73 centimetres squared. Don't forget it's centimetres squared. I know that was a bit of a lengthy video, guys, but I wanted to cover it in a bit of detail. Hopefully that made sense. Hit me up with emails if you have any trouble, and I will see you next time.